Go ahead and get started. Welcome to our annual review. We're basically reviewing 2019 materials, and we're going with a little bit different format this year. We're having the grad students try doing this concept of flash talks. So they're going to try to get their material condensed into this really concise format, and we'll see how it goes. You can give us feedback afterwards. Before I send it off, this is just a really quick introduction. A couple things. First, wanted to say, I think most of you are here who were here yesterday and helped out with everything. I just wanted to extend a huge thank you to everyone, graduate students, and everyone, the staff and faculty who helped make yesterday a success. I think it went really well. Got a lot of great feedback, and I know sometimes maybe you guys don't hear all of the feedback, so just wanted to share that with you. It was really fantastic. So thank you very, very much. So this morning, just to kind of let's try to keep things moving. We're going to try to stick to our schedule as much as we can. We do have a little bit of time and discussions there built in to help adjust as needed. And what we need to remember is to re-mic everyone. So the mic's not for projecting, it's so that we can get the information on the video. And so we have a good audio for that. So I'll go ahead and make this switch now with Olga and get started.
Okay, so my name is Olga Romanova. I'm working with Dr. Gold, and the project is Factors, Influence, and Reasons Behind Agroforestry Adoption and Retention, SARA case study. So why do we need to study agroforestry adoption? As you all know, contemporary agriculture is linked to many environmental problems today, and agroforestry can be an alternative because it benefits people, the economy, environment, while sustaining the required agricultural production. However, agroforestry is not widely adopted in the United States yet, and not as recognized as it could be. So it's somewhere on early adoption stage, and those people, a group of people who are early adopters, are crucial to drive innovation diffusion. So how do we get from a low adoption rate to a higher adoption rate? So it's to increase the number of early adopters who in turn can share their experience, lessons learned, and practices on the ground to other people around, leading that diffusion. So to do so, we need to know who are those early adopters are. What are the reasons behind their decision to adopt agroforestry practices? What kind of what channels do they use to first learn about agroforestry and then find the questions they have about it? And what kind of support system do they have, and what kind of support system do they actually need? Knowing that would allow us to construct programs like SARA, like Center for Agroforestry, and others who strive to promote sustainable agriculture, to construct effective, efficient message and deliver it through effective channels, and provide a sufficient support system. So thus, that leads to research objectives of this project is to identify the socioeconomic profile agroforestry early adopters among SARA case study population, identify the reasons behind agroforestry adoption, and learn more about information channels and support system. How are we going to do that is it's a qualitative study in two phases, and first one is survey, which was launched in December to agroforestry practitioners who got support from USDA SARA from 1998 to 2019. It was like steady, little by little, project by project. And the second phase is interviews, which are in conduction now. This research hopefully will address some of the gaps existing in the literature, which are lack of studies in the temperate zone and developed countries regarding agroforestry adoption, and among those there are a few which actually involve real-life practitioners of agroforestry. There are some inconsistencies in agroforestry adopters' profile and need to look in temporal aspect of agroforestry adoption. Thank you.
Hi everybody, I'm Sergent. My thesis is looking at the impact of a partial flower harvest on the resulting fruit crops in American elderberries. My advisor is Andy Thomas, and my committee members are Dr. Gold, Dr. Revord, and Andy. So my project is looking at partial or different treatments of flower removal. So we go out to a plot of elderberries, there are 6 cultivars, and we count how many flowers are in a plot, and then we make calculations based on that for removal of 25, 50, or 100% of the flowers. This is to evaluate whether or not there's an increase, there could be a possibility of a dual market for the flowers if there's a second flush of flowers. And also to look at berry composition and see if there's a difference or a benefit to harvesting flowers with polyphenols, anthocyanins, pH, and berry size. So, and we also look at the plant morphology, so total height and also number of canes produced to see if that could be affected by flower treatments. So what this is looking at is, so this first figure here is looking at plot berry harvest weights. So this is each plot, this is looking at if there is a difference between the amount of berries harvested by weight between treatments. So we did not find a significant difference between no flower harvest and 50 or 25% flower harvests. And then, so we're not seeing a benefit in yield on that. The next graph is looking at if there is that second flush of flowers. So this is taking into account the 100% flower harvest and the 0% flower harvest to see if we see an increase in the number of cymes produced. Statistically, we did not see a difference. There is a slight increase, but statistically, there's no difference in that. If we look at, so taking those numbers from the 0 and the 100% flower harvests, looking across all of the cultivars, there's also no significant difference between cultivars with the number of cymes harvested. There is, even though Ozark only produced 62 cymes on average per plot, and Rogersville had 156 per plot, there was no difference between those. And then to kind of finish up, this is a photo that was taken at the Chestnut Roast. Felix Fritchie's lab was wanting to test some spectral 3 imaging and decided to fly over the elderberry planting at Hark to kind of get a baseline and work out the bugs for their step. So kind of, which this could be used for biomass, and that far photo figure is just kind of a representation, and we can kind of see each individual plot based in that photo. So, thank you.
All right, so good morning. My name is Raelin, and I'm working with Dr. Sarah Lovell on determining what Missouri farmer preferences are for multifunctional agroforestry systems. And so to briefly describe what a multifunctional agroforestry system is, it's basically a woody polyculture that offers both conservation benefits and production opportunities. So my project can be broken down into sort of 2 areas of objectives that I will be working on. The first is to engage with Missouri conservation professionals and the people working on the ground with farmers to implement conservation programs. I'll be interviewing them to determine what different conservation programs farmers are interested in and implementing on their farms, the different species and planting arrangements that they prefer. And this we'll use to develop a context to design a farmer survey to send out to Missouri farmers and gather from them what their actual preferences are for these systems. So the survey work is definitely in the future, but I envision it as to have different visual representations of agroforestry plantings, maybe some consisting more of a planting that would provide fruit and nut crops, another perhaps more towards timber or solely for wildlife and have the recreational opportunities of hunting and wildlife viewing. And allowing farmers to rate these would begin to understand what systems they're actually interested in planting on their lands, and then perhaps elicit some of the motivational aspects that could be used to encourage them to plant these, the support they will need, and what currently is acting as barriers that's preventing them from going ahead with these plantings. For what I've done this last semester is mainly a literature review to start to tease out from other people's research what barriers and motivators farmers are citing. Some common barriers include just the different social aspects and the tradition of agriculture that doesn't include trees and have perfectly plowed fields with straight lines of crops. And so it's really hard to change and go against the norm. There's the financial concerns of funding the planting of trees, maintaining these systems, or if they're going into selling fruit and nut crops, like what kind of sort of expenditures they would include and would that be profitable. And there's policy. Current conservation programs are very binary. They do not allow the harvest of a crop during the contract period, and so farmers feel that taking land out of production to put it to trees or grasses would not be beneficial. Some motivators that I see as really promising is farmers want to be good stewards of their land. They understand the importance of soil and water quality. They're interested in diversifying their incomes, meaning they understand how perhaps having a fruit or nut crop in conjunction with maybe corn or soy would be really beneficial. And they're interested in providing wildlife habitat and having the opportunity for recreation on their own land, such as hunting, wildlife viewing, and hiking. Some other influencing factors include socio-demographic information, such as age and education, and just a basic understanding of what agroforestry is and the nomenclature around it. If they don't know what it is, they're not going to be interested in having these systems on their land. So going forward, I really want to reimagine what agriculture and conservation looks like by having these multifunctional plantings on the ground that can provide for economic needs, ecological services, and recreational opportunities. And hopefully this can influence policy in changing how we structure conservation programs to better support these dual goals. Thank you.
Good morning, everyone. I'm Yu Xu, and I'm working with Startling. And today I want to introduce a novel technology which can degrade the pollutants in our environment. So first thing is this technology requires skills and techniques from engineering, molecular biology, and analytical chemistry. So this multidisciplinary study gives us the possibility and opportunity to explore the application of this technology. Take atrazine as an example. So atrazine is a widely used herbicide in the US, especially Midwest here, and also around the world. But atrazine is actually toxic to human. It could cause low sperm number to men and then birth defect to women. So that's why it's urgent to deal with this issue now. So first we did some literature review and we figured out that this bacteria called Pseudomonas strain ATP actually has all the enzymes which can completely degrade atrazine to ammonia and carbon dioxide, which is super exciting for us. So we incorporate this bacteria, to our bacillus spore expression system. So as you can see the spores here, there are some hairpin-like protein on the surface. It's really tiny, but we can express all the enzyme on the surface. So as you can see the cartoon here, this is how it should look like, but we cannot see in our eye. So the key finding is, here is the control, and here is our ATZA bearing spores. As you can see here, more than 90% of the atrazine is degraded by the spores within 3 days. And just recall that half-life of the atrazine is 6 months. So compared to the 6 months half-life of atrazine and then 3 days, our spores work super efficiently. And all the atrazine is converted to hydroxy atrazine, which means our spore, they contribute the degradation of atrazine. And expected outcomes, this technology will be one of the most effective technology to clean up the atrazine in a large scale. So we will have clean environment and clean water. Thank you.